Welcome to today's session, ANA304. My name is Kevin Fallis. I'm a Principal Specialist Solutions Architect. I work in the analytics space, more specifically with the Amazon Open Search Service. But today we're going to cover better reliability and uptime with AWS Analytics and Observability. So today's agenda is to discuss what observability means on AWS. We're also going to review open telemetry and the open source offerings that are associated with observability. We're going to discuss managed open source observability offerings that are hosted on AWS. And we're going to review native AWS solutions that are built for observability. Finally, we're going to look at architectural patterns that can help you assemble the components that will give you the capabilities that your business needs to understand how your applications are performing and how your users are interacting with those. So what exactly is observability? Anyone in the audience? John, Muthu? So observability is the act of collecting and analyzing data that's generated from logs, metrics, traces, and things that your applications produce. And it enables you to understand what is happening, not only with a specific application component, but also the entire suite of maybe microservices or solutions that you build to present offerings to your customers. And by understanding the internal states at any point in time, you're able to troubleshoot and resolve issues. And we call this mean time to resolution. The quicker that you can resolve issues with your products that your customers are using, the better your customers are going to be able to interact with those products and, in the end, provide a better solution. So when we look at observability, there are three pillars. The first one is logs. Now, as a developer, I've always created logs for my applications to understand what's happening in the code. And the volume of logs that are generated by multiple applications and microservices tend to be a large volume. But these are just one piece or one component that you're going to leverage to understand what's going on. When you look at logs, there's many of them, and sometimes they're very much in depth. And ultimately, you have to rely on other things to help you figure out what's going on with the system. So the second pillar is going to be metrics. Now, metrics, when you look at them, they're numbers. There might be some aggregations, especially when you're looking at logs and you aggregate in your logging applications. You can then understand things like what is the volume of 403 errors or 404 errors? How many times have I seen this particular event occur, and is it something I should react to? Now, they help us identify trends in time, and they're used to help us understand and predict what our applications are doing and what the behavior of the system is going to be. The final pillar is going to be traces. Now, when you stitch together an application suite, you might have individual microservices, one that handles authentication, one that handles login, one that renders maybe a particular page on your web application or even your mobile devices presented to your customers. In the end, the traces help you understand the overall flow of what's going to happen with your application through all the different paths it might navigate. And this gives you the visibility into the end-to-end flow of all of your microservices or the services you present to your users as a whole. So what is the goal of observability? In the end, what you want to be able to do is improve your end user's experience. And it's all about the experience that your end users have. And so for the applications and services that you produce and present to your customers, you really want to have a full end-to-end view. Just pure logging is not going to give you a good picture. Metrics might give you a bit more understanding of what's happening, but as you stitch together these three components I talked about it gives you a full picture. And so what we're going to do right now is we're going to walk through some of the details around how you gain observability and what the benefits are for your company or for your particular team. So when you look at the observability activity, you have not only an operational exercise, which developers or your DevOps teams will be involved in, there is a business side of the house that you have to be able to influence. And what you want to be able to do is provide proper outcomes. So first of all, the idea is to get visibility. And when we talk through the deck here today, we're going to talk about those components that give you the visibility. The next thing is being able to troubleshoot in real time. So imagine you have millions of logs streaming in. How do you get those logs quickly and efficiently? Does it make sense for your operations team to spend hours paging through application logs to get to what the root cause of the problem is? In the end, you want to narrow down those things really, really quickly so that you, in the end, eventually can provide a better mean time to resolution. So you want to be able to troubleshoot those logs in real time. And what this enables from the business side of the house is that you're able to build highly resilient applications when you finally have the whole flow down. And what this does, in the end, what was the goal of observability? Was to provide a better end user experience for your customers. So right now, there's about 4 emerging use cases that I see. And I speak with customers all day long, every day of the week, other than the weekends. And what I see from the emerging patterns here, the emerging observability use cases, is mainly as a focus on microservices and containers. So with the onset of Kubernetes, containers, and all the microservices architecture, these do produce a lot of logs. And they also enable you to produce metrics and establish those traces. So this is one aspect or one area that people focus on for observability. The second one is the digital experience monitoring. And this is, when you look at an application that you present to your customers, and let's say you're a global business, you might have a handset that is somewhere in Tokyo, Japan, and it is talking to an application backend or an API or a service that you're providing. And let's say that the latency goes up, or let's say that the volume of traffic is so high that that particular portion of your distribution of those services can't handle that load. You want to be able to shift that. Well, from a digital experience monitoring perspective, you want to be able to understand if I have latency in those applications, can I shift that traffic? So not only now you're not looking at just the application suite and the microservices, you're looking at the networking and the overall end-to-end flow. Some people might call this full stack observability, and there's many other names that are attributed to it. But in the end, the goal here is that your application suite is just not what's sitting on your back-end servers. It's all of the components that are involved. The DNS, also the applications themselves, and also your devices that are hosting those applications or those web applications. Another one is Aiops and Devops. It's a term that's been thrown around loosely. It's still defining itself. But in the end, the goal here is that you're leveraging machine learning and you're using some intelligence to also understand how your applications can behave and predict what's going to happen with that application based on trends that your machine learning models might be able to predict. Now, many customers might use AWS SageMaker or Amazon SageMaker. They might use other machine learning services to do this, but the topics that we'll talk about today with the services that I'll run through, some have these built-in features such as anomaly detection. In the end, the AIOps and the DevOps component here are trying to understand how quickly you can deploy your applications into the cloud if you have rolling deployments, multiple times per day, how efficient that operation is, and on top of that, as your application progresses, how well is it trending? If I push out a new product, what's the delta or the difference between what happened now and what's going to happen into the future? Finally, another emerging use case here is data lakes. Now, many of us might have jobs that are running out there, ETL jobs, and a data set lands on, say, Amazon S3, and then it goes through some activities, maybe using AWS Glue. It might go into Redshift, or it might go into Athena. In the end, you want to be able to trace that overall flow, because there might be times that you might have a business that you're delivering data to your customers, and they're reliant on this data. Even your internal customers, such as your CEOs, CTOs, are relying on those reports that happen. You want to get ahead of that so you can provide a great end user experience for those internal customers. So mechanically, the way that observability is presented is that first you're going to detect something. Now, the idea here is with the logs and the metrics and traces, as you have alarms or other things enabled with your monitoring activities, you're going to detect something. This might be through anomaly detection. This might be through, a physical metric that you set a threshold on. But in the end, something's going to alert your team to what's going on. And the next part of it's investigating. Now, again, as I mentioned earlier, you don't want to spend a lot of time scouring through miles and miles of logs. Yes, you might know a specific time frame, but what happens if there's 30 or 40 events over the period of a week? Do you want to page those logs? So the idea is with logs, metric, and traces that you can drill down really quickly into the things that surround that event so you can understand what's happening. So in that investigate phase, that's when you're actually going to interact with the data that's presented to you. Finally, you're going to remediate. And on the remediation side, these can be manual activities presented in your runbooks. They can also be automated activities that you wire in. AWS provides a wonderful ecosystem around Lambda, Cloudwatch events, other activities that can help you automate a lot of the things that you might have done manually in the past. So in the end, the detection, the investigation, and the remediation are the three components that you're going to leverage to perform your observability activities. Now, many times I get the question, is there one tool to rule them all? The observability ecosystem is very much evolving right now. And there are a lot of components that will satisfy your use cases as customers to AWS and also use cases for your customers that you're hosting your solutions for. But I wouldn't say there is one tool to rule them all. And so today we're going to run through what those tools are and give you an idea how you can present an architecture that can enable you to get observability on AWS, whether it be using open source products or managed open source products hosted on AWS or even cloud native solutions. So when we look at the open source observability data collection tooling, there is quite a well-developed ecosystem out there, but there's also some emerging things that are happening additionally to what you currently might know about observability. And the first thing is OpenTelemetry. Now, the OpenTelemetry project is an open source, community-driven project. And the goal here is to be able to provide a vendor-agnostic, cloud-agnostic ecosystem where you can wire in your applications so that they can use a common framework to deliver logs, metrics, and traces to your collecting facilities and your observability tooling. Now, keep in mind that OpenTelemetry is not an observability tool. It is a delivery system to present that information to your tools that you're going to use. So you might think of this as an architecture surrounded around maybe by agents or APIs that you can then present information that can be consumed later by downstream systems. So it does support Jaeger, Zipkin, and Prometheus. And those common wire formats are ones that people have already built. And the goal here is that the OpenTelemetry framework integrates with those so it enables you to get that information quicker to your downstream systems. Now, it is evolving. And there are many talented individuals that are working on this project. And they come from all different verticals and disciplines. But it is a community-based activity. And with these contributions, the goal here is to make a better feature set for people that want to collect logs, metrics, and traces will have them use multiple different components from different providers or different vendor solutions. In the end, the goal is also to integrate with those vendor solutions. So in its current format, and as I mentioned, this is an evolving ecosystem, right? It currently supports traces, which are GA. It is almost ready to release metrics, which is in preview, and logs are experimental. And so when I talk through the architectures, I'll show you how to bridge the gap between that while OpenTelemetry finally evolves to its final, well, I wouldn't say final state, but when it evolves to its final GA state for all of the log metrics and traces functionality that are targeted for the first release. So in the end, the product mission is to enable effective observability and be able to have you use those same components across different cloud providers or different implementations for where you're going to host your solutions. So on the AWS side of the house, what we do is we offer that OpenTelemetry package to you as an end customer, and it is built as a secure, production-ready AWS-supported distribution of the OpenTelemetry product. And the great thing about this is that it's backed by AWS support. And so that's an important thing, especially when you deal with open source on AWS. Having a support line is going to help you react to and get involved in solving issues that you might have with the actual product that helps you produce those logs, metrics, and traces. For many of the services out there, such as Amazon ECS and AWS Lambda, it is a one-click deploy and configure in the AWS console for those, even through the APIs too. There are exporters right now for AWS monitoring solutions, such as Amazon Managed Service for Prometheus, Amazon Cloudwatch, AWS X-Ray, Amazon OpenSearch Service, and other third-party solutions that you might find on the AWS marketplace. Now, most of the time, and historically, people have used FluentBit. So FluentD, FluentBit ecosystem, both an open source, community-based collaborative project. It enables you to have lightweight components, especially on your containers and microservices, that can help you collect logs, metrics, and traces. And there are integrations with FluentBit and OpenTelemetry that will help you push the trace data also to your downstream systems. FluentBit is a fairly robust ecosystem. It has the ability to ship logs to Amazon CloudWatch. It can ship it to third-party partner products such as Datadog. You can ship it to the Amazon OpenSearch service. There are a lot of destinations that you can push logs to, and even the metrics and the trace information. And so when I look at architectures and I look at FluentBit, I look at that as a foundational element coupled with OpenTelemetry. So while OpenTelemetry evolves, I lean on FluentBit for my architecture to help me deliver those other components that are not yet ready for prime time. And so again, this is a plugin based ecosystem. I can essentially tail a file where my logs are going on a container, and I can point to a destination. It might be a buffer that I'm using. It could be Kafka. It could be going to OpenSearch. It could go to another destination. But in the end, all you do is configure this. You build some scripting that allows you to either enhance or refine the data, and you ship it off to your destination. Now, again, FluentBit is a vendor-agnostic solution, and which is really great. When you look at open source, that's what you want to see. And it's built from the best ideas that FluentD had, and it's a lighter weight, when we talked about memory footprints, offering or component for you to use to help deliver those logs, metrics, and traces. And in the end, this provides an extensible ecosystem. Again, integration with Prometheus, AWS OpenSearch, CloudWatch, X-Ray, and all the other components, even integration with Kinesis Data Streams, Kinesis Data Firehose, and other AWS managed open source offerings. One of the newer components that has been established with the OpenSearch open source project is Data Prepper. Now, a few you might be familiar with Logstash. Some people actually use FluentD as a collector. But Data Prepper in its current form supports logs and traces. And what Data Prepper enables you to do, and on top of this being a community open source project, it enables you to collect that data, and more specifically on the trace side of the house. So on the trace side of the house, effectively what it does, it gathers events during a certain time period. Effectively, it's going to buffer it up. And it's going to help you stitch together traces, because when you send a request through, and let's say you do a credit card transaction, the whole time might take a few, maybe no more than a second, but in the hundreds of milliseconds range, right? But in those individual hops, you want to be able to omit an event that has that whole trace span so that you can understand what's happening. So you can understand the latencies, if there are any that are going to transpire in the normal act of producing the services you do for your customers. So in the end, Data Preppers can provide a mechanism similar to what you might see in Logstash, if anyone's familiar with Logstash, but it enables you to filter, enrich, transform, normalize, and aggregate data, and then ship it to your destination. Currently, the destinations that are supported for Data Prepper are the Amazon OpenSearch service and OpenSearch itself. Again, we recently released log ingestion for this, And so traces and logs are supported with Data Prepper, and it's something you'll want to take a look at in your architectures. And in the end here, I'll show you what that kind of looks like when we put it all on paper. So it also has integrations with popular things on the tracing side, such as Jaeger, Zipkin, Open Telemetry, and FluentBit. So when we look at the open source offerings, and if you look at what AWS does, many customers say, I don't want to build this. You know, you have all these wonderful tools out here. You know, I want to be able to, you know, take the open source offerings and host them on AWS. So let's first of all look at the open source offerings, and then we'll look at the managed services that are associated with that. And at the end of the open source part, I will show you an architecture that's purely open source that enables you to be cloud agnostic. You can build this. You can shift across providers on-premises or AWS, and give you a more complete solution that is the same look and feel that you might have if you're hosting on AWS or some other cloud provider. So the first component here is OpenSearch and OpenSearch dashboards. If people are not familiar with this, this is a community, again, another open source community-based project. It's derived from Elasticsearch 7.10.2. And it basically presents you what's called an open search engine, which what was formerly known as Elasticsearch, and OpenSearch dashboards, which was formerly known as Kibana. In the end, this is one of those components in the observability suite, because not only with the OpenSearch project can you look at logs, you can also look at metrics through aggregations, and you can also look at traces with some of the observability tooling and the observability plugin that is hosted with that particular offering in the open source community. Now, it consists of a search engine, and it consists of the OpenSearch dashboards. It also consists of Data Prepper too. That's part of that project. So if you hadn't had a chance to take a look at it, there's a QR code up here, and all of the slides here will have QR codes that you can basically scan and get a little bit more detailed information after this session. So what OpenSearch does is it helps people easily ingest, secure, and search that data that's being produced for your observability activities, such as the logs and metrics and traces. Now, on top of this, there are multiple plugins in the OpenSearch community. And many of these plugins can help you build the observability solutions, such as Anomaly Detection. Now, Anomaly Detection, interesting feature, typically random cut forest algorithm, and what it does, it looks at your data and tries to understand what is normal and then figure out what is abnormal behaviors. And when those abnormal behaviors are detected, it will event and alarm you through an alerting plugin that's hosted on the service. So there's a tight integration there that the anomaly detection can send out alerts to popular destinations such as webhooks on the AWS side of the house, SNS, also Chime and Slack. And so this will help you build that observability solution that helps you easily react to these events. So if you have a chance to, give the project a look. It's a really exciting project, and I'm glad to be a part of it. And I think, you know, as time goes on, this is one of the components that you'll be looking at. Next one's Prometheus. So Prometheus, again, another open source community-based project. And effectively, it's used for monitoring and alerting. And what it does is it monitors and collects metrics. So Prometheus' whole goal is to be a very efficient time series metric collection tool. So again, when you look at the Amazon OpenSearch service, when you look at OpenSearch and you look at what it offers, it gives logs, metrics, and traces, but the metrics are in the form of derived metrics or aggregations. As you find individual numbers inside of your logs, it aggregates them together. Now with Prometheus, you can emit specific metrics at very, very granular times, and it's highly scalable and enables you to then capture the metric information. So when you look at Prometheus and OpenSearch, they're very two sympathetic solutions that will help you achieve observability, because they not only have anomaly detection, but they also have the alerting mechanisms in there to help you react instantaneously to the things that you define as events that you should react to. So it does collect and store the metrics as time series data, and it also gives you the ability to associate key value pairs or labels to this. So you might want to know things such as your cost center, the application ID, and other specific information that will help you then collect that, aggregate that, and present it in such a way that you can discern where those metrics were emitted from. So the project itself consists of a Prometheus server, alert manager, and a push gateway. And typically what you'll find here is that Grafana is going to be used from a visualization aspect to integrate with Prometheus. So again, enables you to gain the insights that you're looking for with numeric measurements. Now Grafana, which I just talked about, is another open source community-based project, and it basically provides a series of visualization tools and connectors that allows you to connect to multiple different data sources, such as databases, the Open Search project, to Prometheus, and other data generating activities, so you can bring those events together all in one screen or multiple screens, depending on how you set it up. And so the idea behind this project is that you can look at these logs, metrics, and traces no matter where they're stored. And so this project, again, too, has an extensible ecosystem that enables you to then build those connectors out and provide the capabilities to understand visually what's happening in your microservices architecture or your solutions. So third-party enterprise data source plugins are also offered so that you can connect into things like MongoDB, Dynatrace, and other tooling that's out there. And that's another feature of the project itself. You know, finally, it gives you the ability to visually define and then build those alerts through rules. And then you can send to destinations like Slack, PagerDuty, and OpsGenie. You know, another thing too is a feature where you can have a split view on the screen and you compare different time ranges for comparisons as you're analyzing those events that, you know, force you to react to them. So in the end, when we look at this architecture, you have open telemetry, which can talk to data prepper, and this is the trace component. You also have Fluent Bit, and which does the logs and the metrics. So the combination of these, now you can send your logs to data prepper if you want, but typically you're going to use Fluent Bit and data prepper to talk to OpenSearch. Then your metrics are going to go to Prometheus. After that, you're going to go ahead and you're going to use OpenSearch dashboards to look at your traces and your logs. And finally, you can use Grafana to look at the data that, or the information that's being produced from Prometheus. Now, another cool thing is when you look at Grafana, it has a connector that also talks to the OpenSearch offering. So you can, if you want, choose to use Grafana instead of OpenSearch dashboards. And so this gives you a lot of flexibility, especially when, you know, your developers or your operational people are used to a specific product. And it also enables you to build for the future. So let's look at the managed open source offerings on AWS. So all these products we talked about, they're managed services. So I'll run through these really quickly. I'm not going to bore you with all the details about it, but in the end, let's walk through this. So OpenSearch, Amazon OpenSearch service. So the Amazon OpenSearch service is a fully managed service that enables you to deploy, operate, scale, and secure your data, not only log data, trace data, and metric data, you know, with a solution, and it's managed by AWS, so you don't have to worry about the intricacies of standing up an entire environment. You basically fill in, you know, a few, you know, pieces of detail in an API or through the console or through the CLI, and magically you have a cluster that stood up, and you can start doing your observability activities. So again, you know, it supports not only the open search engines, which right now in their current version is OpenSearch version 1.2, but it supports earlier versions of Kibana and Elasticsearch from versions 1.5. I mean, think about that. Version 1.5 is old, but customers still use it. But there's still support in the service all the way up to 7.10.2 for the Elasticsearch ecosystem. So for those of you that do use Elasticsearch, consider the managed offering to help you out with that activity. And so it does have all the built-in observability tooling. If you go out to that OpenSearch project, or the OpenSearch project, you'll be able to look at the observability plugin that's been produced It's pretty cool. It uses a lot of new technology, and I think you'll be excited to see what the capabilities are once you get your hands on it. But again, the Amazon OpenSearch service takes all those plugins that you have, not only from the Open Distro framework, but also the OpenSearch framework. It bundles it all up and presents to you a managed service that has all that stuff wired in, enabled and configured, and ready to go for you to start shipping your data to it. Finally, you can leverage things like Amazon Kinesis data streams, Kinesis data firehose. Also, Amazon CloudWatch logs have integrations through CloudWatch subscription filters that also can talk and push data to the Amazon OpenSearch service. So one of the companies that leverages the Amazon OpenSearch service is Pinterest. And how many people know who Pinterest is? Okay, so Pinterest basically, and my wife loves it. She's always, holding pictures and things and new projects for me to work on when I'm not doing my AWS thing. But it is one of the largest visual bookmarking tools and social networks in the world. Many people leverage it, high scale, global. A lot of things are going on, and you need to have visibility, right? And so the OpenSearch service helps them, on the observability side of the house, effectively monitor issues and generate alerts for things that they need to react to. And so what they're doing is a lot of deployments of software that you see going on, or that you won't see going on behind the scenes. And they need to know that if that deployment fails or if there are issues with that deployment. So they leverage that on top of metrics to get an understanding of what's happening with their overall solution. All right, so the next one is the Amazon Managed Service Prometheus. Again, we've already covered what Prometheus is, but again, it is a Prometheus-compatible monitoring and alerting service. All the APIs that you're going to use with Prometheus are presented with the service, and it makes it easy for you to monitor your containerized environments and the infrastructure at scale. It can take millions upon billions of events, depending on how you configure it, and it enables you to get those metrics as you need them for your observability. It will automatically scale to your ingestion needs. Not only the storage and the underlying infrastructure, but also it helps with the alerting and the querying and the operational metrics as your workloads grow or shrink. It's also integrated with the Amazon Elastic Kubernetes service, Amazon Elastic Container Service, and also with the AWS distro for Open Telemetry as part of that offering that I talked about earlier that has support by AWS. So one of the customers, Twilio. How many people know who Twilio is? Okay, if you're familiar with SendGrid, they recently acquired them somewhere back in, I believe, 2019, 2020. But effectively, what they provide is a service of APIs that allow you to send text messages, make phone calls, and other things through an API layer foundation. And when you do this and you have multiple companies that are relying on that service, they have to be on top of things to make sure that they have an effective product to their end customers. So what they use the Amazon Managed Service Prometheus for is to have a fully managed monitoring solution. They didn't want to stand up the infrastructure. They have teams that can be doing better things with their time. And that's the key around the managed services around open source offerings on AWS. You can take your people that typically were building, scaling, standing up these environments and divert them to other activities that make your company money. So they're able to effectively modernize and scale their observability stack by leveraging the Amazon Managed Service Prometheus. So Amazon Managed Grafana, again, another part of that observability component, gives the capability of, again, another fully managed service. You don't have to stand up the individual workspaces or the environments that are associated with Grafana. You can stand these up and start connecting to your data sources and start receiving information. Things that might come from OpenSearch, the Amazon OpenSearch service, Prometheus, Amazon Managed Service for Prometheus, CloudWatch. There's a multitude of sources that you can connect in, even the third-party solutions as we discussed earlier. And so what's nice about this is that you don't have to worry about standing that infrastructure up. And that gives you the capability to analyze your logs, metrics, and traces to fill in that observability solution that you're trying to build. And so you can pull in things from Prometheus, again, Cloudwatch, X-Ray, and even third-party ISVs such as Datadog and Splunk. Now, it does natively integrate with AWS services. And so the console experience gives you the capabilities to add, query, visualize, and analyze AWS data sources across multiple accounts in multiple regions. So one of our partners, which is Contino, they use Grafana for their customers. And in the past, helping their customers understand and get quality observability, they were creating the infrastructure, they were building and deploying, and they found that was costly, right? And so, as a consultancy, you need to be very effective on site with your resources. You might have multiple projects going on, and you don't have time to worry about the intricacies of setting up the security, the underlying components, the EC2 instances that might be supporting this. So now what they do now is they partner with their clients and help them build the best-in-class open source observability experiences so that their customers can be successful without wasting engineering resources to build up that particular offering. And so that allows them to refocus, again, their energy on other things that help their company be successful or the companies that they support. Now, if we take a look at the architecture, not a lot is going to change here. All we're doing is we're taking a open source offering and we're turning it into a managed offering. So again, you have OpenTelemetry, which generates the traces. It talks to Data Prepper. You have the logs and metrics, which go to FluentBit. FluentBit then can push those logs and traces along with Data Prepper into the Amazon OpenSearch service. And then use Amazon Managed Service for Prometheus for your metrics. Now keep in mind, if you are going to use OpenSearch for purely metrics, there's a lot that you're basically storing here. It's not an efficient engine for storing the metrics. It's more efficient for logs and traces. When you look at metric solutions and you look at the things that are going to capture, like high density, lots of individual metrics such as, let's take for instance, maybe a IoT platform. You might have 30 or 40 different metrics that are being generated every 1 second. You're going to need a platform that could take that and ingest that really quickly and have something that's purpose-built. Now, OpenSearch is not a time series database, right? It's a search engine, but it works very, very well at scale for time series data. When you look at metrics, time series database, that's what Prometheus shines on, and this is when you look at these two products together, they comprise that whole solution for you to enable the monitoring of logs, metrics, and traces. So again, Amazon OpenSearch service for the visualization using OpenSearch dashboards, and also Amazon Managed Grafana to do the visualization on the metrics that are in Amazon Managed Service for Prometheus. And again, you have the ability to send logs from, or read logs from the Amazon OpenSearch service using Grafana or the Amazon Managed Grafana offering. So finally, what I want to wrap up here is, I want to talk about the managed cloud native offerings. Now, many people will say, Kevin, I don't want to build all this stuff. Now, again, there is no one tool that's going to rule them all. And so you still have some configuration. But there's some wonderful tools in the tool set for observability that we offer at AWS. First one's AWS X-Ray. So when you looked at what Data Prepper was and what OpenTelemetry has, you have the concept of traces. Well, on AWS X-Ray actually has tight integration with a lot of AWS managed services. So when you think to yourself, if I really want to get started, get running really quickly, I can leverage some of these cloud native offerings because they already have the integrations for the things that I want to observe. So AWS X-Ray helps you effectively analyze and debug your production offerings and your distributed applications, such as those that are going to be in microservices. So you're going to see some integration where you have containers, whether it be on Amazon EKS or ECS, and this integration is wired in with X-Ray. You can find also in Cloudwatch, there's an integration with X-Ray that helps you have one area that you can go to do the visualization around not only the traces, but the metrics and the logs. And so it gives you an end-to-end view of those traces. So again, as I talked about with OpenTelemetry and Data Prepper, when you have a span or a trace span, when I have someone logging in, maybe going and doing a credit card activity, purchasing something, I can understand the latency between those components, and I can hopefully understand if there are issues, which component is causing the problem. And so tracing, again, a very, very important component of observability. So it does give that end-to-end view. It shows a map of your applications. You can even get a map of your applications, much like you can with the observability plugin and the trace analytics with the Amazon OpenSearch service. But again, you can get that full end-to-end view to understand what's happening as a transaction rolls through the system. And so there is, again, native integration with Cloudwatch. And it supports things such as Cloudwatch Service Lens, Cloudwatch RUM, and Cloudwatch Synthetics, which we're going to talk about here shortly. So how it works, effectively, AWS X-Ray is going to help you analyze and debug the applications that you've built. So you're going to collect these traces, you're going to record these traces, and then you're going to look at a service map, and this will help you identify issues with your applications over time if you do have any issues that transpire. So Amazon Cloudwatch, again, integrated with AWS X-Ray. Again, it's a complete observability solution with that integration with X-Ray. Multiple AWS services can have their logs go to Amazon Cloudwatch. Now, even the Amazon OpenSearch service, Amazon Managed Service Prometheus, Amazon Managed Grafana, all of them do have the ability to output those logs into Cloudwatch so you can even understand what's going on with your solutions on that side of the house. But again, it's enabled so you can have that complete observability solution for monitoring and troubleshooting AWS resources and even resources that aren't on AWS, because you can take the Cloudwatch agent and you can put it on your on-premises devices and applications and servers and emit those logs to Cloudwatch if you have the proper networking set up. So it gives you that ability to monitor the applications. It has alerting functionality, so you can respond to those system-wide performance issues. And it enables you to optimize your resource utilization. There are a lot of real cool features that are inside of it that do help you narrow down and help you prescriptively react or understand what's going on with your applications that you're presenting to your customers. So again, we do have with Amazon Cloudwatch integrations with AWS Managed Services and open source tools that give you those logs, metrics, and traces. So you can use the open telemetry ecosystem with other collectors such as FluentBit to actually push your logs to Cloudwatch. So it is, if you look at it, a default source of free health and performance metrics that cover most AWS services and resources. Just about every service is going to emit their metrics, and you'll be able to use those because they're, in many cases, will not be a charge associated with that. And so, you'll get these with zero configuration and zero deployment on your part, so you can understand what's happening with your AWS services. So again, how it works is that you collect the information, and then you monitor the information through the Cloudwatch console, and then you can use alerts and alarms that you set up in Cloudwatch to then help you react. And if you need to discover things such as go into the traces or go into the logs and go into the metrics, you can use the console to do that activity. And it's all wrapped up for you in one solution. So you have X-Ray or Amazon X-Ray or AWS X-Ray along with Amazon Cloudwatch. So let's talk about some of these features. So again, we talked about DEM, which is Digital Experience Monitoring. So if you use the DEM features, effectively, you're going to have things such as looking how to optimize your end user experience. So on, say, an application that you have on your mobile device, you're going to want to understand how that is working. It's not going to be stuff that's going to be happening on the AWS cloud or maybe on your on-premise infrastructure. You're going to actually want to understand what are the latencies? How is the application reacting on the phone for my customers? What are they seeing from the end user perspective? And what's really nice about it, using RUM, is that you can understand that activity and then also use evidently, which enables you to also do A/B testing. So many years ago in a prior life, I worked in ad tech, and we always were trying to understand, if I placed a specific ad in a certain place on the cell phone, would someone click on it? And it was all about generating more ad revenue, but placement in an application of advertising, actually there's a science behind it. And sometimes you want to do A/B testing, or you want to conduct experiments on applications to understand what's happening so that effectively you can reduce risk or unintended consequences when you deploy maybe a newer version. And so this is really nice to have, especially not only testing before you go out the door, but also understanding what's happening when your users use that new experience. The final thing is using synthetics with Cloudwatch. And so in this activity, many times you might deploy an application and it gets out to your customers and there might be a broken link. Or there might be certain things that are happening with the application that were unintended consequences of misconfiguration. And so what you can do with synthetics is you can test those things out. You can understand, page load errors or other things that are important for you to provide a full, end-to-end experience for your customers that suits your business needs. So another customer that uses some of these feature sets is Mapbox. Now, Mapbox is a company I've been working with on a lot of different activities, but what they do is provide open source APIs for mapping and understanding where points of interest are at, or give you geospatial capabilities so you can do navigation and routing and things along those lines. So it basically reaches more than 300 million people per each month. And for a company, Mapbox, which effectively is still in the startup phase, they're really wanting to make sure that there's a great end user experience for their products and their solutions. So by using Cloudwatch, they're able to consolidate, all of their monitoring, logging, metrics, and alerting all under, what I could call a single pane of glass. I don't like to use that term because single pane of glass sometimes implies that it does everything for you. But it has consolidated the activity and the art of collecting logs, metrics, and traces. And so it helps them alleviate that operational burden that's associated with the monitoring activities. And so very little setup required. You just basically start shipping your logs, metrics, and traces, and you can start understanding what's happening using Cloudwatch. And so they use Cloudwatch extensively to monitor error rates and other things that are going on with their API suite. So if we then take the architecture that I talked about before, and we remove all of the open source or the managed open source offerings, you actually come up with a architecture that's even more condensed and a little bit more straightforward. And so in the whole art, you're effectively collecting, you're storing, and you're visualizing this information. So you technically install a Cloudwatch agent. It has the extensions for X-Ray. You can start collecting your logs and metrics and traces, and you ship it to the destination. That destination for traces is going to be AWS X-Ray. For your logs and your metrics, you're going to send those to Amazon Cloudwatch. In the end, you effectively are going to use Cloudwatch dashboards or the visualization options that are provided in Cloudwatch, and then you can see what's going on with your logs, metrics, and traces. Another cool thing here, which I don't have on the slide, is that you can also, if you wanted to, wire in Grafana or Amazon managed Grafana to also look at the data that's being stored in Cloudwatch. And so in the end, these are out-of-the-box things that you configure on AWS. Very little setup time, and it helps you achieve the same thing you might have with not only the open source offerings, but the managed services. So when we look at some of the newer things that are coming out, a lot of the innovation now is heading into the space of AI ML. So artificial intelligence, AI, machine learning, ML, and we use this for observability. And the key thing here is that you can set up a monitoring infrastructure, and you can spend days writing all of the alerts and the thresholds, and then one day your company is wildly successful. Guess what happens? You scale up. And what happens to all of those static thresholds that you've put in there? You start getting tons of alarms. And so this generates a lot of operational noise. And the whole goal here, when you look at leveraging tools such as AI/ML, is to help you, relieve some of the manual burden that you have to do to address what could be happening with your application. So using things like the random cut forest algorithm and anomaly detection will help you understand what is normal and what's not. As your application grows, it knows, I might see a few errors here. Now I've increased my application footprint tenfold, and now I might see 100. But that might actually be a normal operation for you because you have retries built into your code, and the developer's done the right things. They're logging and they're generating a lot of noise. But in the end, if you use anomaly detection, it'll be able to pick up that change. It'll be able to understand that this is actually normal, and it's going to look for other events that then will notify your operations team what's happening. And so there's a lot of work being done right now on AWS in this space. People might use things like SageMaker to build their own machine learning models. And they might use those machine learning models to understand and predict things that might be happening. Other services, such as the Amazon OpenSearch service, have anomaly detection feature. You also have other anomaly detection features inside of Amazon Cloudwatch and also in Prometheus. So when you leverage these tools, they help you get better at what used to be a lot of work. So if we look at anomaly detection again, find abnormal behaviors. You're able to react to changes in your environment, as I mentioned. And you're basically filtering out that noise. So if you use the Amazon OpenSearch service, effectively, you do have a full suite that's related to anomaly detection. It's integrated with the alerting plugin, and it gives you those capabilities to understand when these events happened, and it gives you a couple things. First of all, it gives you an anomaly score, and it gives you anomaly confidence. And so between the two of these, you might have, it's between 0 and 1. The higher the score means that, yes, this is potentially an anomaly, and then the confidence, again, between 0 and 1, also tells you how confident the model thinks that this is something that you need to react to. And based on that score and that confidence level, you can set an alert and you can react to it. And so you can also do the same thing with Amazon CloudWatch anomaly detection feature. Again, you're looking for events that are outside of the norm here and reacting to them. So you don't have to spend as much time on building, the specific alarms, metrics, traces, the specific alarms that are built around your metrics or around your logs, and you can let the anomaly detection features do that for you. So let's talk a little bit about DevOps Guru. So DevOps Guru, again, helps you detect those behaviors that deviate from normal. And so you can identify those operational issues before they transpire. Again, machine learning tool. And it's one of those things that you can add to your tool set on AWS. And again, powered by machine learning. And it's designed to make it easy to improve an application's operational performance and availability. Again, the goal here is that you want to have a nice experience, or a great experience actually, for your customers using your applications. And understanding what's happening fully end-to-end is going to help you be better at that. So it does help you surface critical issues that potentially could cause outages or service disruptions or things that mean that your customers can't access it. If you think about when all of us started working from home during COVID, what was the biggest complaint that you had? I'm getting on a conference call and there's absolutely no bandwidth, or there's absolutely nothing that can help me be on this large conference call to have proper video quality. And so companies will use tools like this to understand what's happening and then react to, and on the networking side, maybe add more bandwidth or more capabilities so that those solutions can work. And so really important to look at AI/ML for the things that you're going to do. But using settings you basically automatically ingest this operational data from your AWS applications. And then it gives you a single dashboard for once you can then you look at those issues in the operational data. So again, how it works is that you select the services that you're going to cover. Really nice integration here. Define the data sources, and then DevOps Guru then will give you metric analysis. And we'll talk about related events, and it will even give you recommendations along the lines so that you can then understand what's happening with your applications. So DevOps Guru is leveraged by Thomson Reuters. Thomson Reuters is a company that provides information to folks. You can go to Thomson Reuters and look at documents or other articles and things along those lines. But they basically produce information for businesses and business professionals to help make decisions in day-to-day activities, might be in the financial space or other business verticals that are similar. And so Amazon DevOps Guru helps them with multiple sources of alerts and monitoring events because it really is challenging to go through all these activities and filter out really what's noise and what's something that you should react to. And it did help them get better at identifying the things to solve those customer critical issues that give a better experience to their end customers. And so they're able to leverage machine learning concepts to help them produce the results that they're looking for to provide a great experience for the customers. So recapping everything, I want to leave you with a few things. So first of all, when you're looking to make the transition from on-premises activities to AWS, in some cases, you might still have to have that on-premises activity. A lot of companies still have older services that can't be ported to the cloud. Of course, we do have offerings on AWS that help you virtualize your older compute and bring it onto AWS. But you can look at open source to have a similar experience not only on-premise but on AWS. Even with Cloudwatch logs and the agents that go associated with that, they can even collect that data with your on-prem devices. But typically, you're going to look at open source for a hybrid solution that you're going to have on AWS because you may want to have OpenSearch and Prometheus and Grafana on-prem with some of your things, but you also want to have that same visual experience on AWS. So look at this if you have a hybrid environment. Again, AWS hosts many open source offerings, and over time, I would expect that AWS has more open source offerings, just looking historically at that. And so think about when you do have these hybrid environments, or you're coming from an environment where you already have things like Prometheus and Grafana. You can use Amazon Managed Services to help you release that operational burden from your teams, and then you can focus on other projects and activities that will make you and your company successful. Now, again, AWS does offer cloud-native observability solutions. And this is not only just for logs, messages, and traces. You also have stuff in the security space that is also out there. And that does help you get started with very, very little setup time. Again, I can't begin to stress the importance of anomaly detection, especially when you have a lot of services that you offer for your customers. You will spend a lot of time in logs if this is your only thing for observability. So consider the logs, consider the metrics, consider the traces as one concise solution. And as time goes by on AWS, and you can already see this happening with OpenSearch and the Amazon OpenSearch project, you will be able to drill in and have a faster mean time to resolution towards the events that occur. And the biggest thing I would say here is that when I talk with customers, there's a general tendency to stay with what you know. Now, this is good in some cases, but many times, some products may not accelerate as fast as the observability ecosystem is going. And so as you look at your architectures and as you look at the components that you use for observability, go back, take the time to understand the capabilities. In some cases, you can save a lot of money with different solutions. And you can help take that ROI or the return on investment with another product that gives you just the same capabilities that you had before, but also a broader and deeper feature set, especially with all the services offered on AWS. And another important thing too is that as you look at these, you're going to ask yourself, okay, I've presented to you Cloudwatch, X-Ray, Prometheus, OpenSearch, Grafana, and it really comes down to a choice, and this is what AWS is all about, is offering choices to our customers. But it comes down to, are you using cost-conscious architecture to provide a cost-effective solution for your business? But with that, I really appreciate your time. Thanks for coming to the session. I know we're at the end of the second day here, but I'm really glad to be out in front of people again instead of being COVID locked down behind my laptop and having conference calls. So I really appreciate your time and investment today. It's been wonderful speaking to you. Any questions I'll take over here. I do need to end the conversation here. So really appreciate it. Thanks.